Hello everyone. Welcome to JVM conference. My name is Roma. I'm glad to welcome all you here. This is Students' Day of our JVM conference. I would be glad if you will like it. We spent quite a lot of time for preparing this, and I really hope this will be a really great conference. To start that, I want to invite here my co-host of this conference, Igor Rubanovich. Igor, I will ask our operator of broadcast to invite him here. Hope he will join us soon. Yeah, Igor, hi, how are you?
Hello, colleagues. Hello. I'm good. Thank you very much. I'm waiting a lot for starting of this conference, and here we are.
Yeah. So like 5 months, right? Something like that.
5 maybe more, because we started to think about, and we started. So maybe half of a year.
Yeah.
Only think.
So guys, we are really welcome all of you here. So this is the opening of the Students' Day. So main part of the conference will be tomorrow. So tomorrow we have full day. Today we have short day, just for you to heat up, to feel the breath of the conference and to start. And tomorrow we'll have full day, full of talks and full of discussions and full of collaboration. Just great day. And today is the great day as well. We will have some good things here for you. So let me share my screen. I have some small presentation to start. Yeah, you see my screen. I see it. Just give me a second. Something happened with my Keynote. Like this is which always happening with when conference starts. Your Keynote doesn't want to load. Where are you, Keynote? What's happening? Okay, just a second, guys. So we need some time to start this presentation to show you all the good things we have.
Presentation don't want to run up very fast.
Yeah, that's.
You forgot to mention that tomorrow we will have 2 streams, and I want to highlight that, colleagues, please take a look on agenda and choose which one is more interesting for you, because 2 different sprints, it's not in one line. We will have 2 lines, so please pay attention on this.
But yeah, so I was able.
Oh, sorry.
Yeah, I just want to say that I was able to start the presentation. But yeah, about 2 streams, this is really important. Tomorrow we'll have 2 streams, today only 1, so it's quite easy. Tomorrow 2 streams, we will tell you more about that. So our conference, Java On, 7th and 8th of September, today the 7th, tomorrow the 8th, that's it. So 3 communities do their best to prepare this conference. This is MGC, this is Minix, I forget the letter Q in Minix, sorry guys, I will fix it till tomorrow, and JaCoV community. We did our best to prepare this conference and to get the best speakers, to great talks and great activities. To fix that, so 3 communities made this conference. Our sponsors is of course EPAM, which provides us a lot of energy and a lot of resources to prepare this. It's We Are Community. It's basically the platform where you saw all information about conference, agenda, and all the stuff. And JetBrains, who provide us some prizes for our activities. So this will be a bit later. I will share information a bit. Also, we have our information sponsors, information partners. This is local communities who helped us a lot to make this conference happen, to share information about it. So you see all their logos there. Communities are all around the world. So thanks for them, like huge kudos to them to help us here. Our social networks. So we have Instagram, special Instagram dedicated to our conference. Here is a QR code. You may subscribe on it. And there would be some nice posts. There are already some nice posts regarding the conference. Also, we have Twitter. So the same thing regarding Twitter and QR code. You may follow us, and there are already some posts regarding speakers and regarding this conference. And next thing is really important. We have Discord server. So this Discord server will be used for communication and collaboration between us and you, between you and speakers. This is really important stuff for you to follow. So here's the QR code. Also, on We Are Community page, on the page of our conference, we have a link to this server. Also, a bit later, I will share the link to the chats, or I will ask our colleagues who currently are watching the chats to share the link to Discord server there. Please join there. And there you have a lot of nice activities. And also there you have discussion rooms with speakers. So, for example, this is how it looks like. you have here some general channels, and you see these student day talks. So here you have 2 channels dedicated per each talk we have today, and also discussion zone. So after the talk, we invite you to go to discussion zone to have some question and answer session with the speaker, so you are able to ask them questions and receive the answers and just discuss the topic if it's interesting for you. So we really encourage you to go there. Tomorrow we will have just the same thing, but for 2 streams, so don't miss it. And something about the program today. Today we have 2 great speakers with great topics, of course. So first one will be Alexander Savin with the topic, why should you wake up tomorrow and start to learn Scala? So if you don't sure yet if you should learn it, definitely pay attention to this talk. And tomorrow, and after Alexander, today, of course, after Alexander, we have Oscar Camacho with a topic regarding Java annotation processing. If you're still not really aware of how it's happening in Java, this is what you should visit for sure. And tomorrow we have full bunch of great topics from experts in Java and around Java from all around the world. These are some spoiler about tomorrow. Today we have only 2 topics. Tomorrow we have 8 and 2 streams. You see the color of the streams on the pictures. And one more thing. So we think to make this joyful and make it more interesting for you, not only for us. So we have a special activity, especially for you. So activity calls while I'm watching Java On. So this is the picture I made yesterday. I'm not participating, unfortunately, but you may make a picture of how you're watching Java On conference and post this picture with tagging our Instagram account in Instagram, of course, or tagging our Twitter account in Twitter. And among people who did that, we will make a we will give you an IntelliJ license, basically. So don't miss a chance to receive IntelliJ license. This is kind of simple. So information about that would appear in Discord, in channels. Quite easy, quite simple. And basically that's it what I wanted to share. Enjoy the conference, of course. So Igor, how do you feel before the conference?
Exciting. I'm wait a lot of time of this. So when it started.
Well, it's starting right now, so I would like to invite here to our virtual studio our first speaker, Alexander Savin, and the moderator of this talk, Tatiana. So please come to us and we will discuss the talk, which will start right now. Tanya, hi. Hi, Alex. How are you?
Yep. Hello, guys. Nice to be here. So, Alexander, the stage is yours. Yep.
So Alexander, may you share with us what would be your talk about? Maybe some general info?
I think on start of my presentation, I will share the information. So it's kind of spoiler, your question. So if you...
It's a spoiler.
That's exactly what we wanted for.
So if you're ready, we can start.
Yep. Just a kind of question from my side to our amazing hosts. Guys, have you had an experience writing some code in Scala? Because I did, actually. So, what about you?
I do, and I don't really love Scala, so I don't think I'm the good person to ask this question to.
I'm just only talks from my side about Scala, and I'm not really think so far that I need to drill in Scala. But after Alexander's presentation, maybe I will change my mind. Let's see.
Okay,
but
so
watching us, please write your opinion about Scala. Do you like it or not? And what are you waiting from Scala? Please share your experience about this.
We are just about to start the talk. The very last thing I would like to say. So guys, we basically have 3 chats where you may send us questions. We see your comments about microphones. We will try to adjust them during the talk. So 3 chats we have. First one and the main one is here on YouTube. So right here you may write us some comments, and if you write it on YouTube, we would be able to share these comments on the screen and everyone will see it. Second chat is in Discord. So in Discord you have a chat which names exactly like the talk you will listen right now. So why should you start learning Scala? You may write your questions there as well, and we will take these questions from there. Tanya, our moderator, will pick the questions from there for this talk. And also, we have a chat on Where community platform. So you may also write questions there. We will try our best to have a look on all three chats. I could not promise you that we will, but we will try our best to do this. Okay, I suppose that's it. Let's start the talk. Good luck, guys.
So let's start. Can you hear me? Tatiana, can you help me with the understanding what sound we have sound and we have vision of my presentation?
Yep, everything is cool. I see and hear us now in the stream. So, yep, let's move on.
Oh, cool. So let's start. And first of all, a couple of details about me. So my name is Alexander Savin, like Roma mentioned before. So I live software engineer at IPAN, Spain. So some highlights from my experience. I have 10 years of experience with JVM languages. My key competences in general is high-load architectures. So I like distributed systems like Hadoop, like Kafka or Spark. I like to work with the system that maintain the stream processing. And the core things from this talk, I Scala language enthusiast, so I like Scala. That's it from my side about me. And the short note before I start. So please feel free to disagree with the statement that I will make during my talk. So all of the decisions have trade-offs. So we can discuss it in the channel, in all the channels Roma shared before. So feel free to ask questions, highlight the disagreement with me, and that's it. And the next point in my list, so please don't make the assumptions or decision on the things that I will share with you during the talk, because it's not so productive ready things. So be minded and decide accordingly with your production system. So let me describe a bit the format of my talk. So it's only 1 hour. I have the intro and 3 topics. And just to let you know that after each topics, I have the short gap. Then you can ask a question. Probably Tatiana will made it vocally, and I have a chance to answer. The significant point, I will share a lot of code in Scala. Like we discussed before, yeah, it's kind of new. I expect that it's a new thing for you, but feel free to skip the code, because the thing that I want to share is kind of idea about the things that we have in Scala, not exactly the examples of the code. My talk have name, why should you wake up tomorrow and start to learn Scala? Let me start with the similar things. I think all of you wake up tomorrow, definitely. And I think you wake up for learning because you're here on the Java On conference, so you're prepared for that. And the last part in my title is a Scala. I have a couple of images about what is exactly the Scala. It's a kind of model for auto or theater in Milan, but I don't think it's the topics that I want to discuss today. Actually, the things that I want to discuss is the Scala programming language. Some things that I want to highlight before I start about the language itself. So we have a short history summary. So in 2001, in Switzerland, Martin Odzierski started the language, and language have the second version in 2006. And right now we are in the process of the migration to the third version of the language, and that was initially started on 2020. Main point that you can run Scala on different platforms. But first of all, we are on Java On conference, so we mostly talk about JVM related topics. So most of the, almost all of the things that I will share with you related to running Scala on Java virtual machine. So Java can have the branches for execution with JS or Scala native, but it's out of scope for my talk. Let's start. So here on the slide, I have the ranking for the Scala languages for current year. And the Scala, you can see not on the top. So the question that we have, why we should learn Scala? Because it's so small and so kind of unpopular, I can say. And the answer looks like this. So it's the funny thing, but the answer is related to this meme. So let me, first of all, highlight the Scala properties that I think should be considered during the selection of the language. First of all, I think that Scala is not your first programming language. I think all of us on Java on conference have the background for the Java. So please start with Java as well. So it's not the thing that typically people start with Scala itself. I think the next point that Scala is kind of niche language. So we use it for the specific occasion. And that's why it's kind of small. The next two topics that I want to highlight that I kindly disagree, but it's still the factors for this kind of smallness. So first of all, I disagree with the thing that typically programmers say that Scala is for high society. In this specific case, I mean that to learn Scala and to understand the language, you have to know the category theory or upper side functional topics. But I don't think this is true right now. And the main point that typically related to Scala, that Scala is kind of better Java language. Let me start with such topic in detail and highlight that for a significant amount of the learners is a common way to Scala, so as a better Java. Here on the screen, I have the two programs that I written in Scala and in Java. So, and this is the thing that we typically name better Scala. It's just a more compact way to express yourself. So here you can see that on the right side, we have Scala program that kind of significantly less verbose than Java one that we have on the left. As an outcome of that, so yeah, you can agree with me that it's a less count of lines of the code, but as this meme said, okay, Java have this issue for years. So what's else? And what else? I think that as a Scala language, Scala introduced a lot of things that typically right now in process of adopting to Java. So like you can see on my table, so time to time, Scala have out of the box all of these things like lambdas, type inference, sealed classes, and Java on the next version have probably most of all, but not yet. So, and I can say that Scala is a kind of source for features of features for Java. So right now, pretty impressive that Java on the way to pattern matching implementation, because I have it from out of the box from 5 years ago as minimum. So it is a kind of intro. So it's kind of general description about the Scala language. But my talk is what we have in addition to this term better Java. And my approach is to give you 3 types of things. First of all, to share with you how you can efficiency model the things with Scala, how we can use it with frameworks, and what kind of frameworks really based on the Scala. And the third one in my list is kind of special things that I think Scala is mostly valuable for. Let me start with the first one. So I think the idea of reprogramming is how to express or model the world efficiently. And I think the more easily we can do that, the more efficient is the language. I can give you two types of examples with the explanation how the Scala simplified such topics. So first of all is algebraic data types, and another one is blueprints with the help of framework of Zio. Let me start with the first one. What is the algebraic data types? It's kind of simple. It's kind of concept. So let me make a step back and explain the general approach for the programming languages. You have kind of model that you have to implement with your program. We have a lot of terminology in this area. So like model, special language, bounding context, but like the picture describe it. So we have a vision in our mind. So the basic points for our program, like in this case, I try to model the hotel booking system. For every hotel have their rooms, every room have the price, and we have a relationship between the price and room by booking. And of course, booking have the guest who make this thing. If we move forward with that, so we, like I said, we have a relationship between such topics. Let me ask yourself, let me try it in another way. So in the school, we made the same relationship between other things, like we have algebra during our education. Like we have national numbers, we have special operation like sum operation or multiplication. We know the laws between this operation, like associativity. And the question here, is it possible in general to make such approach with the algebra to the model that we have, for example, for our hotel and booking? And the answer, yes, we can do that. So we can do the relationship between the domain objects and maintain the laws. With the Scala language, so you can do it easily. So here I have the example of the implementation of the booking system with the Scala language. You can see here that we have rooms, we have several types of rooms. We have several types of guests, several types of prices, and the booking system. The main point here that we can maintain the laws between such entities. So typically, we have two types of such things. So sum or. So it is implemented by Scala classes and Scala traits and case classes in the Scala case. So we have a pattern matching and all of the things from the language to express this. So like you can see on the screen, so the language itself help you to not skip gift type in the function. So the compiler will warn you about that. So the language itself help you to build more safety code. Another type of the relationship is a product. It's a simple one. So for example, booking have the components, so then they combine the room, the guest, and the price. So it's kind of product. With such approach, then I showed you before, so we express the relationship with the Scala language. But the question here, is it algebraic data types can be implemented with other languages? Yes. And Can it be implemented with Java? Yes, of course. So here I have the examples of the implementation with a different version of Java. And return back to the features that Scala have out of the box, I could say that Java is have the evolution, but still we have not all of the features. Even with the last Java, we still don't have patterns in switch statements. So I have to enable preview to implement that. But if I compare the last Java with the last Scala, as I have to do, so the last Scala 3 have even less implementation boilerplate. So we have just a couple of lines in addition. Let me make a conclusion. So I think that algebraic data types is a good representation for your model. It helps build a laws for this and try to maintain such laws in general is the main idea of the programming. And the Scala have the support for these things out of the box. So it's just ready, you can use it. The next point, what the other tooling that helps you to express the world or implement the things that you have outside of your computer. So is blueprints with Zio. So Zio is a special framework that based on Scala, and Zio generalized the conception of the calculations. So here we have three type of things. So we have environment type as an input, and as an output we have one or another, even error or failure type, even success type or kind of result that we expect. I think from this perspective, it's kind of more, it is as much as general representation for any calculation. Here I have the explanation what I mean about the blueprints. On the left, I have an example of the simple application that reads your name from a console, waiting for 3 seconds for that, or fall back to default one name, and output the hello message on the screen. Actually, the representation of such program in with Zio framework, it's actual blueprint, so it's a plan for execution. So on the right side, I have the same representation as a graph, or maybe kind of representation of actual blueprint. But you can see that we have kind of plan for the execution, and only with such plan we run it with a special method. I will return back to that a bit later with the additional features. Why? Because some of the audience could say it's a typical thing that have the functional programming languages as monadic computation. I don't want to dive deep to the question because my colleague Karin Alexandra Manoid have the brilliant talk tomorrow that I will appreciate you can attend. And I think Karin Alexandra shared a lot, much more information about functional programming and especially Scala or Java implementation for such things. Then I can, then I, with the limited amount of time for my talk. Let me make a summary. So I think the Scala is a language that perfect for modeling the world. We have two types of examples here. Algebraic data types, like I said before, is a good idea. And we can express the laws with the really compact syntax that Scala can give you. And another example that we can sketch the blueprints for our program logic, and as well with Scala and help with Zero framework, we can do that. So I finished my first topic. If you have questions, I'm really glad to answer.
Actually, I think that we have more like comments rather than questions. So I will sound some of them because we have a lot of stuff which has been said, and I think we will proceed with some more comments later on. But yep, some inspiring points like I love Scala, especially type inference is wonderful for my laziness. Yep, and there are some discussion points like Scala is good for using with Spark, which I think will be the next part of your speech. Spoilers, sorry guys. Yep, and the point that there is kind of a bit long comment about some concerns regarding Scala, so I think we will discuss it later on, nearer to the end of the speech, because yep, it's rather interesting to hear your opinion on that. And yep, we have some comments in the community platform related to the fact that guys have started to learn Scala and it looks great so far, but need to see it in action rather than in toy examples, and I totally agree with that. Yep, so one more quite a long comment, but rather interesting. I think Scala is awesome. Just learning it will improve your coding skills, better object-oriented design, better use of type safety, functional programming, immutability by default. However, it's not an easy thing to learn for many people. It requires a sort of mindset change from imperative programming. Missed. Yep, which many are reluctant to make. I believe that the reason why Scala is not so popular, and there are not too much good framework to use, like Spring and Micronaut don't support Scala officially. Using them with Scala feels forced. Scala framework like Legum are kind of intimidating. So, yep, I think this is the point which we also are going to discuss next. Am I correct?
Yeah, definitely. So it's exactly what I want to highlight. So we have kind of answers in our next slides.
Let's move on.
So let's move to the next topic. And I have the interesting term on my screen, lingua franca, or common language. And this is the thing that I get from the Wikipedia. So definition for lingua franca is a bridge language or common language, a lot of things that with the language in the end. But the idea here that all of us, or most of us from different countries, and have the original language different. So we have to convince or agree on the common language that we can talk. For this specific case, I talk with English, not my native language, but I understand we can communicate with that. And the thing that I could say that lingua franca for Scala written frameworks is actually Scala. So that's why the Scala is the core point here. Let me start with explanation of some of the frameworks that we have based on the Scala. First of all, and first in my list, I think all the Spark, Apache Spark is the first in the list for Scala language for every discussion. I think it's really widely used engine for scalable computing. So the Spark can be executed on different platforms. You can set up the standalone Spark cluster. You can leverage the Yarn resource manager or just run it on a Kubernetes. Spark provides you the ability to batch or streaming processing. A couple of topics here that Spark has special language as Spark SQL and special abstraction on top of the distributed data set as data frames. So, of course, Spark is a widely known as a framework for machine learning, because most of the operation will be applied on the memory and is a significant game changer in comparison to, for example, Hadoop. The point that I want to highlight here, Apache Spark have Scala as a source code language. So, and I have kind of joke here that in the quick start tutorial, they have only 2 options for you. Of course, they have a lot more options in the other pages, but I really surprised that on the quick start, you have only 2 options recommended by Spark documentation. You have to use Scala or Python. Of course, the thing that I want to highlight, so if we have framework written on Scala, so here the Scala is a kind of lingua franca language. I don't want to dive deep to the Apache Spark more than the couple of minutes. That's why, because we have tomorrow the brilliant talk, especially for that. So Oleg Klimenko will share with you the information how to run Spark. So the interesting topics that will be covered with this, and I think it's core point of the talk with a live coding session. Let us switch to another, not only Spark based on the Scala. Apache Kafka is a well-known distributed log framework as well have their core on the Scala language. Kafka is a conception of distributed log, like I said. So we have actually queue. So the queue is distributed over the topics. Every topic can serve the producer, and consumer will read on one topic on several topics. The system and framework well known as highly available and the key point of exactly one processing. So the Kafka is scalable event streaming platform written on Scala. Of course, here we have a lot of things in Java, but as I mentioned before, the Scala is the core language or such framework. I think that is kind of things that you have to do. So if it's written on Scala, the easy way to interact with the framework is the Scala itself. Let me switch to the next framework that I have in my list. It is my favorite one, actually. So it's an Akka framework. If you don't know about actor model, I will encourage you to understand the concept of that. Akka is the implementation of this actor model on the JVM. Actors is actually actors, so they act with some. So they receive. Actor is an entity. In the entity receive the messages. Every message can change the internal state, and this kind of the things, this simple concept, give us the 4 points of reactive architecture. So we could build a responsive system, resilient, be elastic, and like I mentioned before, actors itself message driven. So if you don't know what is reactive manifesto or reactive system, please follow the link that I shared here. I like the Akka a lot because of that. So with the help of such framework, you can build reactive system easily. And the things here that Akka as well based on Scala. Here I have the simple example. I understand that on the left side, the Scala is much more smaller than the same implementation for the actor behavior on the left side with the Java. The Java itself is pretty obsolete, so I understand that with the final Java, the code will be much, much smaller, but the fact that the documentation for current moment looks like this, so the maintainers of the akka, of course, enforce you to use Scala as a main language because it's too much easily in comparison to Java. I have to highlight some of the other frameworks that I summarized here with less attention to that. So we have Flink based on Scala. It's a special framework that gives you the ability to maintain the stateless computation on the streams. We have Finagle as extensible RPC system. So here we have the answer to the question in the chat about the framework. So Finagle from Twitter, they built on the Scala the kind of framework that then you can build a network stack for distributed system. So I think that it's kind of recommendation from my side about such environment to build such things. And from the other area of the spectrum, for the load testing, we have a Gatling. Gatling is a framework to build load test of the code. So if you want to test your application in a performance characteristics, like, of course, it's usually the kind of HTTP service or something like that. So the Gatling is the thing that you help to express your patterns and reach your goals easily. And as well, Gatling based on Scala. So I think they just encourage you to write the patterns in the Scala language, and that's it. Let me make a conclusion. So I think this terminology about lingua franca express my point very well. Scala is a lingua franca for Spark, Kafka, Akka, and our frameworks. They have the source code in Scala, and the compact system on the Scala encourage you to use the language because it's too simple to communicate the Scala written frameworks entities, and that's it. So we have next area for the questions.
Yep, and there was a question which basically related to the previous section, but I unfortunately didn't have enough time to sound it yet. So the question about the algebraic data types, which type of natural numbers does Scala use? So is it starts from 0 or from 1? So kind of classical programming feature, like to start calculation from 0 or from 1. How does Scala work with that?
I think the algebraic data types is a concept. So I don't think it's related to this specific topic. The representation for the numbers on the Scala is integers or longs. So I think it's slightly unrelated to algebraic data types. But from the idea of algebra data types, you can implement the logic by yourself. So and we have a lot of such implementation in the functional programming frameworks that I don't have time to express here. So for example, you can define something like non-negative number, and this have to be a non-negative number in any case. So if you have the boundaries, that's it.
Okay, got it. And yep, two more questions which are mainly related to this section in particular. So first one, what would you say about the performance of Scala compared to PySpark? Back in time, I used Python for our Spark-based project. Would be interesting to know what could be improved there and whether it's worth rewriting it in Scala.
I don't can't recap it completely, but well-known book from the area is High Performance Spark. And High Performance Spark, as I remember, said that if you have a choice between the Scala-based computation or Python-based, of course you should use Scala because it's kind of native language. The Python itself translate your computation to the bytecode by Scala framework. So I think it's more natural way to use Scala as an origin language than the Python here.
Okay. Sorry for being possibly a bit loud. Yep. Actually, the next question is about the frameworks as well. Have you had an experience to use Akka as a production project? An in production project? Yeah.
Of course, yeah, several times. I think so. I think it's a tricky question. So in the past, yes, I have a lot of examples of the production working application. The trickiest of the question that right now the Akka in kind of gray area with the change of for license. So for the future projects, I think it's a kind of the questions. Should we use the Akka itself or fork of the Akka that I think we'll have in a couple of months. So I think guys from Zero try to fork the concepts of the actors as well.
Okay, thank you very much. And yep, I think that there are a lot of questions in both of the chats, so I will leave it nearer to the end because they are not directly about this particular section. So let's just move on to the third part.
Perfect. Let's just move on. Let me make a recap. The third part is description for the special cases that I think the best match for the Scala. I have two examples to share with you. First of the example is domain-specific languages with Scala. Let me express the topic. Domain-specific languages is a kind of things that we have domain terms. I think a good example, just to simplify things, is plain SQL. SQL, it's not a programming language. So it's kind of specific language in specific areas. And the things that I have on the left is applicable for SQL as well. So it's easier than arbitrary programming language to read or write. It have limits. So for example, it can't, or I don't know how to write the special SQL query that express, for example, arbitrary computation or arbitrary program. I don't think it's possible. So we have limits. But on the other side, every domain-specific languages have the requirements. So they have to be interpreted in some way. So we need an interpretation phase. So we have to transform with domain-specific languages to our form to execute. And as an outcome for the previous point, we need supported tooling, because if SQL fail in some point, in some cases perform worse, you have to have the special tools to understand what's going on here, how to get the point of the bottleneck. I think SQL here is a good example. So you have to do it for if your SQL query doesn't perform well. So we have special tools like explain or other things. Depends on the relational database you use. The point here related to Scala that for some specific cases, we can combine both of the things. You can use the Scala language itself without additional interpretation as domain-specific language. And it will be validated in compile time. Let me provide you an example. You can see on the right side on my screen the example program. Then I try to write the currency converter. So we have euros, we have bitcoins, and we try to convert one each to the other in some form. With Scala, it is possible out of the box. So let me provide you just two of the several things that we can leverage to express such language. So first, it will be the methods with operator names and expression methods. Here I have to highlight it again. So I understand that the Scala programs itself is not the things that you can understand out of just from scratch. You can see that maybe it's kind of cat that walked on the keyboard and that's it. But I have to recap. The idea here is to express the ideas. So just follow the ideas that I will share with you. Doesn't matter that you don't understand the program itself. So first of all, Scala have the point of operators. Well, it is impossible with Java. So in Scala language, you can define the methods with arbitrary names. Like for this case, I defined the method with the plus name, and I can just express the amount in euros and amount in the bitcoins and sum them with the just plus method. So it's just a regular method. You don't have to use dots in the Scala world, and you just can type it on a line, and it will be the valid code in Scala. The next point that I want to highlight is that we have extension methods. For the same class amount, you can define the special methods that can express and apply some function on it. For this specific case, we can define expression methods with the names euros or bitcoins and the value of such things like kilo bitcoins or kilo euros or mega for the euros, and it will be the valid code. So you can just define 21 kilo euros or 5 bitcoins, and that's it with the Bitcoin well-known icon. So I don't think it's possible in Java. If you know the way, in the compile time, feel free to say me how to do that. So let me express the idea again. Scala at some point can be just the DSL itself. So it's just a plain Scala. So as a final of my previous implementation, I defined a simple language. When I defined euros or bitcoins with a plain language and just make a sum of them with the result. So you can see that I just want to highlight it's plain Scala language. So it's not kind of interpretation of the something that we have to transform to JVM onto the bytecode. It's just a plain Scala language. So here's the idea. So we can use the Scala language as a DSL itself. It is a kind of highlight conclusion that I already made. So in addition, I want to say that it's not only two things. In addition to that, you can leverage other things like smart constructions, implicits, and all of our syntax sugar that Scala provides you to simplify the definition of your DSL. Sorry, but I don't have enough time to express it in a full way. The next point that I want to touch a bit is a program as values. It's another area that I want kind of the areas then Scala give you the more power than other languages. Here we return back to the example that I have on Star with Zio framework. and blueprints, like I mentioned initially. So the same program. Just to recap, so we have a hello message. It asks for the name for the user, wait for 3 seconds for the input, and fall back to unknown name, and greet the user with the name. And here, I want to return back to the conception of blueprints. In addition to just concept of blueprints, we can think about it like from the execution perspective, what we can do with blueprints. And like blueprint for the building or some machine, the things can be executed, of course, like a program, but we have another properties, like one blueprint can be composed with other one. So we can combine them together and run together. So it's the good property that we can leverage. In addition, of course, our blueprint can be introspective. It's like a blueprint for building. It can be reviewed by qualified engineer and can be improved. So the good point here that our blueprint can be optimized, and the result will be much more optimal than initial one. And all of these things can be done in our interpretational phase. Of course, if we have a blueprint, the next point that we actually can serialize or deserialize the blueprint is the good property, especially for distributed execution. And here we return back to the power of Spark or Akka framework, when you can do distributed computational on a lot of nodes. And the things that then you have the plan or blueprint of your computation, and it can be serialized and spread across the network. Of course, it's a critical value to have the easy distributed computing. Another point that I just want to highlight here about the program as a values. So as a blueprint, it's a kind of value you can share, you can serialize or combine. The interesting thing that with example of Zero framework, we can not only combine things, but because it's our rules or our laws that we maintain, we can ruin them. For example, our program just wait 3 seconds and after that fall back to unknown. Typical approach here, or common approach in the unit testing, is just to wait more than 3 seconds a bit and test that we have something in the output. With the Zero framework, when we have the blueprint, we can break the laws and just to adjust the time. It's just the adjustment of the time in the context of our execution. It's not the real time. So you can see here we don't have to wait 3 seconds or more. It's executed in the milliseconds. So it's another point that program as a values give you as an idea. So you can the value itself can be interpreted a bit differently. So you can break the rules and, for example, adjust time and just maintain them. So of course you can imagine that you can run a lot of tests in the same 3 seconds in comparison to just common approach. Here, all of the things that I want to share as program as a values. I don't think it's kind of full explanation of the idea, but just my approach is to give you kind of things to think about and to return back later with the kind of ideas. Let me just make a general recap. So why to learn Scala, actually? First of all, I think all of you, if you start with Scala as a better job. But in addition to that, you you can leverage some of the properties. Like you can model the world efficiency with the blueprints or algebraic data types. Of course, interaction with the frameworks that have the lingua franca as a Scala, like Spark, Kafka, Akka, the interaction with them can be much more easily because with the Scala itself. And for the special occasions, like construction of complex DSLs, or especially DSLs when you can use, if you want to use the compilable Java Scala code. And blueprints that I mentioned before. So then you want to use the programmer's values when you have a plan to execute, and after that you want to combine some things or distribute the computation of the frameworks. So the Scala have a lot of features and benefits on such areas. And I consider you have to use the language for that for sure. And of course, it's not the full list of the properties here. So let's just have fun and learn Scala for fun, for sure. It's a valid point. And that's it. So thank you for the attention. It was the last topic in my list. Tatiana, I think if we have questions, I can answer. But before you highlight some of them, in addition, I want to share with you some of the materials that can help you on the path to Scala. So feel free to see it on the screen.
Yep, and I think we definitely will attach all the links below our event in the community platform. So please feel free to return back to the page later, and we place the links to the comments. So basically, you've already replied to one of the questions, which sounded like which books you would suggest for learning Scala. So yep, it's amazing. Actually, we can see all of them on the screen. Yep, and returning back to the questions from the very beginning of our sessions. So there's a point like, I worked with Scala for 2 years and have several concerns. So first one is slow compilations. The next one is binary incompatibility, which makes Scala upgrade especially difficult. Binary incompatibility means if you use any libraries written in Scala, they are not compatible. I mean, you want to use a new Scala version, your code won't work with the old libraries. So what do you think about that?
Let me answer by points. What I remember the last question about incompatibility for Scala version, but what is the first one?
The first one was about slow compilation time.
Okay. It is true about the slow compilation. So then I switched to Scala. So right now it's kind of magic for me. Then I return back to the Java world and just compile the Java programs, and it was really fast. I think the answer to this question is is it exactly the problem? So if you think about the experiments on your idea, the Scala have a lot of tooling around with the caching and how to help you to compile really incrementally. So from the developer perspective, I think it's pretty solved. From the maintainability perspective, so if you compile your Scala code to the bytecode and just execute it, you have to do it only once. So I don't think it's a problem when your CI/CD system compiles. So the difference here is, I don't think it's kind of critical one. So the second question is about the incompatibility, binary incompatibility.
Yeah.
The Scala community make a lot of improvements in such area. So your experience with the Scala, the compatibility, not of the Scala 3 with the Scala 2, especially Scala 2.14 version. So the language and compatibility much more smooth than, for example, Python 2 and Python 3, despite the version match here. So my answer here, Scala community improves such things a lot. So I want to encourage you to recap and try it again, so just to get the real experience.
Okay, got it. Thank you. I think we have time for something like 1 or 2 questions more. So I will also return a bit back to the questions from the platform. And guys, I would like to point out that in case if your question is not answered during our session, do not be afraid. We will continue our session in Discord. We might sound some questions there. And if you're not going to participate in this discussion, then also do not be afraid that your question won't be answered. We will try to post as much questions as we can below our talk on the community platform with replies from our speaker. The last, I think, question which we still can sound during the stream. So let me choose something interesting. I think that okay, so this was something which we've already heard. With operator overloading, is the precedence of all user-defined operators equal? For example, is 1 plus 2 multiply 3 equal to 7 or to 9? So with precedence or without it?
Good question. Partially, yes. So I can't provide you exactly the mechanism itself, but with the naming and so, for example, this kind of definition, then we know that multiplication is a kind of star in the Java language, and in plus in the is a summary. Scala have order of such method names, and I think for the simple cases it will just work, but you have to check. So partially, yes.
Okay, got it. Roman, do we have time for 1 more question?
I think no, we have time pretty off. Sorry for that. So first of all, thank you very much for great talk. Thank you very much, Sasha, for opening our conference. And thank you, Tanya, very much for moderating this and bringing questions here. So guys, just a reminder, first of all recordings of all our talks will be available on our YouTube channel and here on We Are Community platform, so you may find it there. And yeah, we will publish all the talks after the conference. Now you may go to Discord and there is discussion zone there. So if you have more questions regarding Scala and you want to discuss it with Alex and Tanya, feel free to join discussion zone on Discord. Link, I'll post it to the chat right now. I will try to post it again, like everywhere. So it goes to YouTube and it goes to We Are Community. Yeah, here it is. So join our Discord server and you will find discussion zone there, and you will be able to discuss this talk with guys. So guys, I want to show you something before we move on to our next speaker. So let me share my screen. So here you may see that I have our Discord. This is where you can join. You may see the links in the chats, like mostly in all the chats. So here we have different activities, right? So first of all, everyone who joined the server receive a nice intro message in server intro, and we ask you to share some information about you in general chat, just like your name, maybe where you're from, and that would be enough. Maybe some sticker just to make it more fun and good. And also you may open the community activities, and here you may see that somebody already posted something on Twitter, right? So somebody made a picture of how they watched the conference, and they posted on Twitter, and I will both take it from Twitter and push it here. Also, we have the same integration with Instagram, so please post photos how you're looking for Java on Conf, how you're watching Java on Conf on Twitter or Instagram. You may see hashtags here on the top of my desktop, and we will have it here. So just let's bring more fun to the conference. Also, we have one more activity which can give you ability to win IntelliJ license. So here I have special activity for Java on Cryptography mini challenge. You just need to go through the link. There is some form, some task. You may solve it, and everyone who will solve this task, we will select the winner for IntelliJ license. So this is a chance for you. Somebody will join us tomorrow. They will have I suppose less time, and even maybe they don't have this activity there, so it's only for you. Don't miss your chance and participate in this nice activity. The winner will be announced tomorrow on the closing of the conference. And saying this, I would be glad to invite here in my virtual studio our next speaker and moderator of his talk. So our next speaker is Oscar Camacho. Oscar, hi, and moderator of this talk, Igor Rubanovich. Igor, hi again.
Hello again, colleagues. Wow, it was very, very interesting, but for today it's not all. And now it's very important and interesting topic. I believe that all of us using these annotations in your code, but somebody don't know how to implement this. And today Oscar going to show us how to implement annotations in the easiest way. It's really not complex. If you don't know, you will see now.
Okay, Oscar, may you share with us some thoughts or some words what your talk would be about and why it's important for everyone to hear that?
Yeah, well, hi everyone. So basically, my talk is about how to implement your own annotations and how to process them. This is like the stepping stone into building your own framework if you are really into that sort of thing. And even actually, we're going to take the focus on how to generate new Java classes based on the annotations that you are actually going to build. So we are going to take a look at a use case and scenario, as a really simple one. And we are going to generate new classes on the fly right now as we go along in the talk.
Great. Just some comments we have here that maybe you may turn your microphone a bit louder if it's possible.
I will try, yeah.
Okay. While we're waiting, I have a question, Igor, maybe to you, just to discuss. So a lot of people who use frameworks like Spring or similar, they say that like they don't like annotations. They say, okay, it's some magic. I don't really understand that. This is something really strange. So what do you think about that? And Oscar, same question to you. What do you think about these thoughts?
For Oscar or for me? Sorry.
For you both.
Okay. Okay, yeah. Just for me, I understand such kind of mindset, because when you debugging something and you see that annotation producing some magic, you will not find what happens inside. So annotation must used with understanding what happens there and implemented for understanding. And sometimes annotation, of course, can cause some performance issues if they will implement it in the wrong way. But of course, all in our hands. We can do bad things and we can do great things. It depends on us. And Oscar, what do you think?
Yeah, I agree almost entirely with you. I mean, if you you need to know what happens under the hood in order to actually make good use of your own annotations, of all the annotations that the Spring provides. It's not magic. I mean, you just need to browse through the docs a little bit and to actually sit down and comprehend what they are saying. Most of them are going to explain if whether or not they generate a new class, or if they are going to analyze it using Reflection API. Something will happen over there, but it's not magic. Basically, you just need to understand what is going to happen, why, and what are the shortcomings of using that type of annotation, and what are the pros of doing that. I think that one of the most, for most of us who use Spring as in a web environment, we can all agree that Spring annotations do make our life easier, in the sense that we need to write much less code as opposed as in the older days. Back when it was only Spring MVC, we had to write like these enormous classes. And right now, I mean, it's just like add rest controller, and you add a simple method, post mapping, for example, and that's it. You don't really have to spend that much time coding anymore, and that's the beauty of using annotations, I think.
Yeah, totally agree with what mentioned. So yeah, guys, let's move to the talk itself. Just a reminder, we have 3 chats basically. One, and the first one chat is on YouTube channel. Second one is in our Discord server. So join there. There are some activities, and also you may find there the chat specially dedicated for this talk. You may leave your questions there. And also we are a community platform where you have agenda and all information about the conference, and they also have a chat. So all 3 chats you may use. We try to monitor all of them, to questions from everywhere. So don't miss a chance to ask your question to our speaker. I became silent. Good luck, Oscar. Good luck, Igor. And Java is on.
Okay. Just give me 1 second.
Yes, sure.
Uploading.
Yeah, so how we see in the comments, annotations are lifesaver. Yeah, sometimes it's totally true that just use one annotation and you will no need to duplicate your code.
Yeah.
Okay.
Yeah. So let me just interrupt you a little bit more. Let's start with the actual talk. Sorry for the delay. So basically, well, welcome everyone. My name is Oscar Camacho. I'm a lead software engineer here at EPAM Systems, and I've been actually with EPAM for over 2 years now. And well, basically now we're going to talk about Java annotation processing. And well, the subtitle of this talk is how to create your own annotations and generate code with it. Let's review really quickly the agenda. We're just going to check the theoretical side of things. We're going to review what is an annotation, what is annotation processing, how to create your own annotation, and how to process it. Then we will move to reviewing the actual code that processes the annotation. Finally, we will have a Q&A session. So you can follow along once we reach the code part. You can start downloading it or just browsing it. It's these 2 links are, well, the QR code and the link will guide you to my GitHub repository, in which I have the code. Feel free to fork it, to clone it, do whatever you want. It's a sample repository, so you're free to do whatever you want with that code. Either way, we're going to go around the same slide and the QR code, so you can also access it later. Okay, so have you ever been in this situation in which you work for a project that has like multiple objects with the same behavior, and even though it's a good practice, you start to feel like reusing code becomes a really repetitive task, and you would also like to spend more the time you are using reusing the code itself, doing something more productive, like doing something new, something like that. So we have the solution for those type of situations. Well, actually Java does, and they are Java annotations. An annotation is basically just any code fragment that gives more information about the code that they are annotating. They are identified by using the @ character or whatever they call it in your country, and they are mostly used by frameworks or libraries, and they just use it to flag some information or behavior of how to do things. So, for example, right now we are seeing an example of a Spring REST controller, and it's just having a get mapping, and it's precisely what I was talking about earlier. It's really concise, really clean code, and really minimal code, and that's the purpose of using annotations. So what is annotation processing? Annotation processing as a whole is just to extract information from an annotation and use it to your favor. That being said, annotation processing can occur on several parts of the lifecycle of the program. So, for example, as I mentioned before, Spring sometimes relies heavily on using the reflection API to obtain the information from the actual annotation. This type of processing we're going to refer to as runtime processing, which is slow and actually quite compute time intensive. So we are going, for the purpose of this talk, we are going to refer to annotation processing, to the one that occurs at the compilation time. So right here, what we are seeing on our left side of the screen is an example of an actual implementation of how to process an annotation. We're going to review this afterwards, so don't worry. Now let's just review really quickly how to create your own annotation. Basically, you just need to either create your own Java file, preferably, or modify an existing one and add the reserved keyword @interface followed by the name of your desired annotation. And so, as you can see in this example, we just need to we define two attributes for this annotation. These are not mandatory. Annotations can be empty, that in the sense that they can't have any attributes by themselves, or they can also have default values, which we are also going to review later. And yeah, I mean, just to use them, you just need to make a reference to it somewhere in the code. Okay, now let's review how to process your our own annotations. Basically, what you have to do is to have ideally you should have a separate project, and more on that later, in which you have all your annotations and the processors of your annotations. That is because you want your annotations to be as independent as possible from the actual code that you're going to annotate with. And for doing a processor, you just need to create a new class that extends from abstract processor, sorry, which is a JavaX a JavaX class, and it's an abstract class, so you need to implement the process method. On that implementation, you must obtain all the information of all the classes or elements that were annotated in your in the code that you are processing. And once you have that, you need to react to that. Either you can do multiple things. Right now, what we are going to focus on creating a new Java file, which is like the most standard approach. You can create new Java files, you can create new .classes files, even .properties files, or other type of file, and it's perfectly valid. You can also make several things over there. I probably by now, many of you are wondering about Lombok or similar alternatives. We're going to discuss them a little bit later, and how is it that they actually modify classes for existing classes in order to achieve their goal. So now let's review the benefits of using annotation processing. When we use compile time annotation processing, it is, well, the generated code can be up to 10 times faster than equivalent code using Java reflections. We're going to have a live demonstration on that. The code that is, well, that you end up with, the actual code base, is going to be easily readable and even reusable across multiple projects. In the sense that, for example, your annotation that you create for one, you can make use of it on another project, and so on and so forth. I mean, we can have an example of a Spring framework. So a Spring, it's not like they built their annotations for a single type of project. Actually, they are supporting multiple types of projects, so it doesn't really matter what type of project or what your project is. You can also always make use of the same annotation over and over again. It also enables teams to focus on more complex tasks, also by reducing the time spent in repetitive tasks, and it makes the code significantly more readable. Now, let's review really quickly a use case scenario. For this, and just to keep it plain simple, I know that this already exists in Project Lambda, but bear with me. So we are going to make our own builder annotation, and basically what that means is that we, for example, imagine that we are working in a project, and a backend project in which the performance is like a key directive, right? So we have like several entities that have a constructor with multiple parameters, right? So, for example, imagine that each entity is a map one-to-one to a database table in a relational database. So you may end up with, like, I don't know, like 10, 12 parameters in a single constructor just to build a single entity, right? So that's not really readable, and it's actually quite confusing over time, and we want to avoid confusion. And also, the team is looking for a more readable way to instantiate these entities. So in the traditional sense, you would make a call to new entity and pass the parameters to the constructor, and whatever objects are not considered in the constructor, you're going to assign later on. And yeah, so that takes up a lot of lines of code, and if the code is not correctly maintained, it can lead to a quickly unreadable code. So we want to avoid that altogether. So we are proposing that we build a builder annotation. By how are we going to go about that? Is by, if we have here a class diagram in which we are going to just review really quickly, like the main players. So we have an abstract processor, which is the class that's exposed by JavaX in order for you to actually build your own implementation of the annotation processor. We also have the abstract annotation processor, which is our own implementation of the abstract processor, just to try to have like a common logic built into it, so that we don't have to worry about how to extract the actual classes that were annotated with our annotation, and just focus on validating them. We're going to transform them, as you can see in the second method, and that's because the information that is provided to abstract processor are JavaX elements. Those instances are quite complex. They don't have like a one-to-one relationship to something that we may know in code. So, for example, we know that classes have attributes, classes have setters, getters, and so on, right? That doesn't quite correlate to what JavaX elements are described to be. So in order to reduce that type of complexity, we're going to transform them into a model of our own. Plus, it also helps us with the lifecycle of the element instance itself, as that's managed by the compiler. and we don't really have like a real mechanism to actually create new elements on the fly. So in order to avoid that altogether, we are going to just transform that to a model of our own, which is described in the descriptors package. Again, this will contain, for example, class descriptors, method descriptors, constructor descriptors. The basic things of a class and all its elements are going to be mapped over here in our own model, with things that we know and love and comprehend of the Java programming language. The actual implementation of the annotation processor is going to be handled by the annotation processor that will implement the three abstract methods that we defined previously on abstract annotation processor. And just as a quick note, the finalized element processing will have a direct call to an instance of builder class writer, which is an implementation of Java class writer. That is the class that we created to basically have the logic centralized for writing a new Java class. This particular Java class writer will make use of the filer object, which is exposed by the processing environment by a abstract processor. So we will take a look at that and how is it that the filer object actually allows us to create new classes. Well, new objects and new class files or source property files, whatever. So let's review the code. Let me just now, I'm going to share my screen. I'm going to present. Let me change this one. Well, actually, first, let's stop right here for a little bit, just so everyone can get the code if they haven't. Again, both the QR code and the tiny URL are going to direct you to the code on GitHub, and that's like the latest version right now. So feel free to to download it and to do whatever you want with that code. You can use it as a template, whatever. So let me just now share my screen. Igor, can you help me add my screen to the presentation, please?
Hello again. So something freezed. Oscar, can you maybe try to reshare?
Oh, okay, yeah. Let me reshare now.
So colleagues who are watching, looking for watching us now, and if you have some questions, please do not forget to post them into our chats, YouTube or Discord, everywhere. You can ask, because it's rather technical tech talk. So maybe something not clear, you can ask, of course, and we will handle. So I see we are good with screen sharing. Please, Oscar,
Okay.
go ahead.
Thanks, Igor. So, okay, we're going to start really quickly with the POM. Since this is a Maven project, you can make use of Gradle if you want. I just find it Maven to be somewhat easier to explain. So, as any good old plain POM project, Maven project, sorry, we can have properties. It doesn't really affect the way that we are going to make use of our code itself. However, for this particular code, we are going to make use of this library exposed by Google, which is auto service, and the scope is quite important to have it as provided. Yeah, the version it keeps updating, so check back with Maven repository to find like the latest one. But overall, this is like the sole dependency that we are going to make use of, and you're going to see exactly where we are going to make use of it. And it's actually just to use another annotation. So don't worry, it doesn't do much other than registering your own processors for the compiler to make use of them. Other than that, you can add as many dependencies as you want. For example, right now we are making use of JUnit and JUnit parameters just to make testing a little bit simple. As far as build plugins go, it's not necessary to declare all of them. However, this is, the compiler plugin. It's one that you may find useful to declare it in your own implementation. Right now, we have it set up with the configuration tag to force the Java compiler, and that's so that we can debug properly our processor. Otherwise, maybe we'll fall back to JDK tools, and it will make use of that compiler or compilers or whatever. But if you force it to use the Java compiler, then whatever error you may have while actually developing your own processor, it will be much easier to track down, as it will provide you with more information of where and exactly why it broke. So that's useful to have. Other than that, the short-firing plugin is just for the testing part of the project, so don't really worry much about that. So let's dive right into the actual code. Well, I think one of the most interesting classes that we're going to review is the abstract annotation processor. So basically, this processor will use two generic types, two type parameters, which is A for annotation. All annotations in Java are extent of this. I guess it's an interface. So you can make that shortcut to find if the class that you are using as a type parameter is actually an annotation. So that takes some part of the validation out of the way. We are using an M to represent the model itself. And that's just so we can, in the process method, as I mentioned, it's the actual method that we need to implement from abstract processor, which will actually do the actual work of getting all the annotated elements. So as you can see over here, we are going to have a for loop in which we are going to iterate over the elements that are provided by the method round environment, get elements annotated with. The round environment, we have to think of the round environment as a compilation wave, in the sense that let's imagine the code state, right? So we're going to have the initial state, which is the state at which the code started with. So imagine you just did a Maven clean, right? So you just have your source files and nothing more. So with that the round environment is going to correspond to that first state of the code. Once the first annotations are processed, they're going to generate new code, right? Or do some side effects. So once that is the first round is finished, you're going to end up with another round that recompiles all the code plus the new files generated. And that is done iteratively until nothing is left to compile. So that's what round environment is, and that's why we are using it to obtain the elements that were annotated. So and just for simplicity's sake, we are just obtaining the elements that were annotated with annotation class, with our annotation class. Otherwise, it can get a little bit tricky when you're trying to process annotations from a whole package instead of a single class. So just bear that in mind. It's not impossible by any means, but it tends to get a little bit more complex over time to maintain that code and to actually have it on something useful. Now, So every time we are iterating an element that was annotated with our annotation, we are going to have three main methods, which is validate element, which will actually verify if the element that was annotated with our annotation makes good use of the annotation itself. The second one is transform element to model, which is, as we've described earlier, just the part in which the model, well, the JavaX element is going to be translated into a model of our own. For our project in particular, we're going to make use of the descriptor package, and more on that a little bit later. And finalize the element processing, which is the last the last method that we need to implement, which is the one in which you can do whatever you want with whatever element you annotated. So that's like the logic of all of this. All the abstract annotation process or implementation are going to follow. And we also have some quite useful debugging tools such as print error message. So imagine that you have an error while, well, you encounter a uses of your annotation, so you should throw an exception. In this case, for example, we created the bad annotation uses exception, and just you throw an exception stating that the user, well, the developer is making bad use of your annotation, and that should be a compile time error. So that's how you're going to print the actual error itself. So let's take a look at the actual implementation of this, which is the builder annotation processor. Now, as you may saw, the previous class was an abstract class, and that's because that's going to be like the common logic that all processors should have out of the box. But the actual processor that is going to be called by the compiler, it's going to be this one. So that's why we need to annotate this this class with these three annotations. The first one is supported annotation types. Well, it's not really necessary to annotate that, but to annotate this class with this, but it's like the easiest way. Otherwise, you need to implement the get supported annotation types method. So there's like really no good need to actually do that, and since you're always going to return a constant, so that's why it's useful to use this particular annotation. Over here, well, actually, this annotation will receive a set of, well, at least a collection of strings corresponding to the package, well, to the fully qualified name of the annotation that you're going to support. So in case you do want to support multiple annotations, you can do that. Well, you can define them over here. Right now, we are just going to support only one type of annotation. So there's not really a need to do that. As far as the next one, which is supported source version, this one is quite interesting because you're going to state which version of Java you're targeting your annotation to work on. So obviously it will work upwards to this, but that's like if you ever work with Android, for example, this is like the mean SDK attribute, in which that's like the minimum released version that you need to in order to make use of your annotation. So in this case, it's release 8, which is, I think, up until this day, the most common one. So that's I think that will increase the compatibility of your code. Now, this is the actual the annotation that we described earlier by Google Auto Service. So this annotation, what it's going to do is going to register your annotation to the compiler itself, so that it make use of it it registers it, and the compiler knows to make a call to this processor in order to process any code that was annotated with this annotation in particular. So that's quite useful. That it's the only actual external dependency that we're going to use throughout the project. You can make the actual registration yourself, but I just think it's really easier to just make make use of the Google dependency on this. So moving forward, as we stated before, the abstract annotation processor, a builder annotation processor is going to extend this abstract annotation processor, and our annotation is going to be the builder annotation. So if we review that really quickly, it's your typical builder annotation. It's quite similar to something like the Lombok one. Maybe the field, the name of the attributes are a bit different, but they are mostly the same. And what I wanted to review over here is actually these two annotations that annotate our annotation. So basically, the rotation it's going to refer to how at which point in the code execution lifecycle is going to the annotation is going to be present. So we have multiple options for this. We have this tree. So source, as it was before, it's going to describe all annotation that should only be present in the actual source and will be deleted after the compilation has finished successfully. Class, on the other hand, does somewhat similar, but it's not deleted after the compilation time. So that's like the main difference over there. There are more, but those are like the main to remember. And runtime, basically the annotation is going to be available once you're even as your code is running. So for example, if you're going to do something such as the reflection API processing, you may want to make use of the runtime retention policy. But for us, since we know that we don't want to process it on the fly, we're just going to make use of source as such. The target, it's actually one of the most useful ones in order to validate your own, to automate as much as possible of the validation of your annotation, but it's not going to be fail-proof. So for example, when we specify the element type to be type, what we are saying is that most classes are going to be able to make use of this builder property annotation. Sorry. However, it does not exclude, for example, abstract classes or final classes. Something else. All the combinations in between. They cannot be they will be considered valid by the compiler. So you still need to validate them afterwards. And that's where the validate element method comes in. Basically, we need to validate for simplicity's sake on this example. We're just going to validate if the annotation is being used in something other than a class, which should never happen since we have the target annotation. This case should never happen, but either way, we are handling it just to be safe. And on the other hand, the other edge case that we are not going to be supporting right now is abstract classes. So for simplicity's sake, we don't want to implement abstract classes. So yeah, that's going to be that. And it's just to demonstrate that we don't want to do it. In this, if you annotate, for example, an attribute or another type of element, you may have other parameters to validate whether or not they are using your annotation correctly. So let's move on to transform element to model, which is the actual, let's say, hard work that you actually have to do. So the element interface is going to expose an utility method, which is accept. This what it's going to do, basically, we need to it's going to allow you to obtain all the information regarding an element from let's say in a standardized way. So in order to do so, we have this class named typeMapper, and we are extending this class, which is also provided by JavaX, which is element kind visitor. The number is basically for to state the Java release that it's the target of. So, for example, if you were to analyze this code with SonarQube or something code analysis tool, you may find that this class is going to throw an error or a smell, saying that it has like too many parents, which is not allowable. But that's okay. Well, I mean, I think it's okay because the way that these classes are designed to behave is that basically the newer version inherits from the previous version, and so on. And so basically, right now we have version 18 of Java, so we now have well, we have a pretty extensive list of element kind visitors. So, for example, if you wanted to implement, for example, the 14, you are going to have like I don't know whichever number of versions before 14 was for Java, so of warrants. So that may throw a smell, but it's nothing to worry about. There's nothing you can do about it also. So yeah. Over here, we are going to have the element kind visitor will have several methods in order to actually have to analyze certain elements in a certain specific way. So, for example, right now we since the builder annotation will only annotate classes, we're just overriding the visit types class, but we can have several other methods that we can override, such as variables, packages, enums, interfaces, type parameters, exception parameters, the throws clause of a method. Those are the exception parameters. Modules for certain Java versions. Yeah, I mean, you can name almost every type of element inside any valid Java element is going to be visitable. So you just have to find like the correct combination of element that you want to visit and how to analyze it. So for our sake, we're just going to analyze the class. However, that's easier said than done because, as you know, describing a class is not just getting its name. We also need to have like the setters, the attributes, especially for a use case which is a builder. So for that, we need to also analyze the enclosing elements, which are the elements contained by the same element. And over here, we're going to extract information for constructors, the fields, and methods, and if not, well, we just don't analyze it as a whole. But I mean, you can make this as complex or as simple as you want, depending on your needs. So the type mapper, once it obtains the translation to or the script to the objects in our descriptor package. So for example, right now we're going to obtain the class descriptor because we are typing classes. It will return that, and afterwards, this is just like utility methods for obtaining a mapping between setters and the actual attributes, which are going to be useful for our builder. And we just return the model that we're going to use, in this case, the builder annotated class, which is a model, an object that we created to contain all the information regarding the actual annotation and the class that was annotated. And finally, we get into the interesting and I think the most useful part, which is the finalized element processing, in which we are going to build our actual class. So let's take a look at this method. The general builder class of the builder class writer is just going to make a call to write file of the Java class writer. And over here, it's the actual magic part that we previously described. So it's not actually magic. We're, as you can see over here, we're going to make use of the JavaX filer, and the JavaX filer is going to expose several methods. In particular, for this one, we're going to make use of create source file, but we can also make a create class file or create resource. So whichever one you prefer and whichever one suits your needs better, you can create one over here. Basically, over here, and once you created the source file, printing to it, it's just like printing to any other file. So they generate the file, which is a Java file object, is going to expose a writer. So you can make use of whatever writer you want, the buffer writer, whatever. The actual implementation doesn't really matter. Right now, we're just making use of print writer because it's quite simple. And we're just going to write the class itself. Our class itself is going to extend from generated class, so that well, in generated class we have our toString method is going to have all the logic necessary to create the actual class. No, so for example, it doesn't make sense to have like a private class or a protected class or whatever. So we're just going to default public class, and you can hack your way around building your class in such ways. And that, I mean, the beauty of it is that you can make it as simple or as complex as you want it. I mean, processors are still Java code, so you can make it as you want. It doesn't have like a set of rules over here. Right now, we're making this quite simple. As you can see, we're hacking our way around it, just so we don't build any unnecessary code or non-valuable code to us. So once that's out of the way, I want to present to you the two test subjects, which is fake class happy path, which is a happy path for us for a builder because it doesn't have a constructor. So by let's say by default, the Java is going to provide us with an empty with a public with no parameters constructor. And over here we have a default constructor. Well, we don't have a default constructor, and also the constructor does not consider all the attributes of the class. So the way that we are going to build the actual code itself, no, sorry, I don't want to use the terminal. So it's by just like any other Maven package. You need to just run Maven clean install. Clean is just to remove the previous files that you created, and install is just to trigger all the lifecycle. So in that way, you are going to trigger also the lifecycle of the compile lifecycle, and on that by doing so, you're going to execute to build your own classes. So right now we have these two, the fake class happy path, which is these two are the results of these two classes that were previously annotated. But just so it's quite clear, we're going to run it live. So clean, so that Maven deletes these classes, and you can see by yourself that we are generating the actual results. So right now it's now running the test. So we have a build success. And over here, if we open it, we can see that this is our generated class. And okay, as you can see, it's going to throw an error right now because it's not correctly linked in our project structure, but the class should work by itself. No need to worry over there. This is the class that we generated ourselves. And wait, close that. Okay, this is the other class that we generated when we don't have a default constructor. So as you can see, we are going to obtain like the least parameter constructor, and then afterwards we just need to populate whatever fields are missing. So those are working just fine. Now I want to demonstrate the actual benefits by doing another demonstration of how to implement the code that we show right now in an actual project. So this is another project, and as you can see, it's called Reflective Builder. Let's take a look really quickly to our POM file. Over here, I mean, just a really standard Maven architecture. However, the only sole difference that we do have over here is that we are having the dependency of our previous project, just to make use of the annotations and the actual files that we are going to generate. So the way that this project works is it's just an actual demonstration of how the builder annotation is going to be faster than our newcomer reflective one. So if you can see over here, we have two classes, and we are timing how much time it takes to insert each of them. So we have the doc class, which if we review that, we're going to see that doc class is just a simple class with these 4 attributes. And basically, what the only thing that's different from this class is that it has a static class that extends from the reflective builder, which is also a class that we built just to centralize all the common logic for building a class using a reflective pattern. So basically, over here we are obtaining the class that we want to analyze. We're obtaining the setters, the attributes, and we're doing the mapping ourselves. However, we do need to state that this analyze part is going to be done on runtime, so that's why it's going to take a little bit longer. Well, quite a lot actually, and also because the reflection API it's just slower overall, and it shouldn't actually be used but in performance sensitive applications. So yeah, basically that's that. It doesn't really do much, as you can see in the actual implementation of the doc builder. We just set values, and since we're making use of a map, so we can we need to pass like the name of the field, and we need to know the name of the field that we are going to set. And if that's incorrect by whatever reason, that's going to be an issue, because it's not going to find the actual setter for that field. So as you can see, it's quite sensitive to, it's error prone, and it may not be like the best solution after all, but it's a way that you can do that. On contrast, we have the Swan class, which is the same class actually, well, only different name, but same attributes, same everything, except that it's using the add builder annotation we created. So if you see over here, we have the import for the annotation of the other project, which is the builder. And again, it's same class, same setters, same getters, same everything. So now what we are going to review right now we already generated the class, but we are also going to do it right now. Okay, so we have this is the generated class, and the benefit of using the Swan builder as opposed to the builder, the reflective builder, is that you have type integration built right out of the box. So you're going to have, for example, set name, and it's going to know to receive only strings. For example, set cities flown to. If we see our sorry. this is not the class. It's this. So if we see the swan, where is swan? So here's one. So the city is flown to, it's a list of strings. Also, order is not important, so you can do whatever order of calls you want. So set city is flown to, set if it knows how to fly, the number of feathers it has, and basically just a call to build, which is going to return us the actual instance of Swan. And again, we'll just have like the timing of each instantiation, just for simplicity's sake. So, sorry, again, wrong. We're just going to clean install it, just so you can see that we're going to generate the Swan builder again. Okay, so we got success, no problems over there. And now we need to run the class. Just run main, just so you can see the actual difference in performance. Right now, as a side note, I'm plugged into the AC current, so times are going to be much faster as opposed as if I was unplugged. So, but we do have a significant difference over here, 10 times actually, somewhat more than 10 times. But yeah, I mean, the dock instance that was built using reflection took 29 milliseconds, whereas the Swan took only 3 milliseconds. So that's a significant performance boost over using reflection. Again, it's not that I hate reflection, but it's not meant to be used on performance-sensitive applications. So just have that in mind, that it does have its benefits of using this one. Now, as promised, I was going to talk to you about Project Lombok. So Project Lombok is quite a controversial project for the annotation processing world, because it makes use of some, and the best way to describe it is hacky maneuvers to actually make to actually modify an existing class, as you could saw in the simple annotation project. We were creating new files as opposed as modifying existing ones, and that's because that's like the intended behavior for Java, to create, not to modify. So that's the way that they do that. Unfortunately, they do have like some hacky behaviors. If you check out the GitHub repository, well, of Project Lombok, you're going to see that even in the discussions, they mentioned that if the approach that they are using, if it's correct, some enterprises do have like a security concern of using Project Lombok. So if that is your particular use case, that you are not able to use Project Lombok, don't worry. For most of the use cases of Project Lombok, you can make your own annotation and make the code yourself without having to modify the actual class. And in that way, you can also, the way that you're going to solve it, as opposed to Project Lombok, is by making use of the hierarchy of the Java classes hierarchy. So, for example, if you want to override a class that you built by adding, I don't know, a setter or a getter, you should make a class that extends from your base class, which adds these new methods. So that's the way that you're going to handle all of it. But I mean, I understand that it's quite convenient. Project Lombok is quite convenient, but again, it's not like the silver bullet that we hoped it for be. So that's about it for my demonstration. Let's move on to questions. Does anyone else? Well, let's move on to the Q&A session. So just let me fetch over here thanks.
Hello again. So, Oscar, it was amazing. It was very, very interesting and very technical. I believe guys who was not aware about annotations now learn it and be ready for example, interview questions or improve project. I like your way how you show that that performance can be increased. Cool. Okay, so we don't have a lot of questions so far in chat. Let me double check. Here, and in the Discord. I guess you showed a very clear topic, and our colleagues have no questions here. But I
may-
have one question for our
No,
colleagues.
before
Sorry,
before
Roman.
before you proceed with questions, we have first of all the comment that annotations are a lifesaver, and it helps us reduce much of the boilerplate code which we may have. And also we have a comment that it was a great talk. So Oscar, thank you very much.
Thanks, Roma.
Yeah, thanks. And so, from my side so far, a question to our auditory who watch us. Well, Oscar, I saw that you are using IntelliJ IDEA and night mode. Just Holivar, colleagues, who of you, which mode are you using? Why day mode, light mode, or night mode? My project is like Holivar sometimes. So why we waiting answers? Oscar, second questions to you from my side. What you can suggest to person who first time in life will start writing his own annotation? Just suggestions, couple of suggestions from your experience.
Yeah, my suggestion is to try to keep it simple. Try to keep it independent of what you want to do and reusable. That's like the main point of of making a good annotation. Make it as reusable as possible and make it as independent as possible.
Good suggestion. Thank you. So we have a question from Anton Lukyanov. How was created annotations which are use it for creating custom annotations?
Okay, so basically you want to have an annotation to create a custom annotation. That's what I am understanding. The same way. So basically, let me reshare my screen. Okay, so as you can saw in the Java class writer, we are creating a source file. The source file, how JavaX understands source files is just any old .java file. So in that sense, you can create your own annotation for building your own annotations. I mean, quite a retrospective way of doing things, but yeah, I mean, that's possible. There's like no side effect, no problems of doing so. What I think you shouldn't do is to build your own annotations, well, your own processors based on code generation. Not because you're not able to do so, but it's not like an operation that you want to automate so heavily, because it does have some tricky bugs down the line. Mainly trying to know what you are mapping, especially in the JavaX element side of things. So yeah, I mean, it's completely possible. I'm not against it, but you should tread carefully. That's like my main.
I totally agree. Cool. So I believe it fully answered. No more other questions, and we see answers on the first hour question. Most of modes I see it's a dark mode, night mode. So light mode is not so popular in nowadays. Roman, and which one you are using mode?
Black one. Dark mode and theme dark.
Dark
of course.
mode on. And our Java on today is in dark mode.
Yeah,
It's funny.
yeah, exactly. So I suppose saying that, I want to thank you, Oscar, again for your great talk. It was just awesome. So thank you very much for being here with us and share your experience. I hope it was useful for all the guys. Yeah, by the way, we have a lot of comments, the dark mode in We Are Community platform. So guys, now you have ability to move with Oscar and Igor to our discussion zone in our Discord server. Don't miss a chance to ask Oscar a lot of questions regarding the annotations and how to work with them. So I will post one more time this link to Discord server to both our chats we have here. So please join guys in the Discord server and you will be able to discuss it with them. Thank you again. Thank you, Oscar, for your talk. Thank you, Igor, for moderation. Good stuff, guys. Thank you very much.
Thanks.
Thank you, Colin.
Okay.
See you tomorrow.
Yeah, see you tomorrow. Okay, so that's it for the first day, I would say. Thank you very much for everyone who was here today with us. Tomorrow we have full day of the conference waiting for you, so don't forget to join us tomorrow. Not to miss it, please go to We Are Community platform if you haven't yet and click register button so you won't miss our tomorrow's stream, and we will be there. A lot of great topics, a lot of great speakers. Just a reminder, we will have a talk from Java champion from Oracle Dmitry Alexandrov, and we will have a talk from Google Dev expert Karina Alexandra-Manoid regarding functional languages. So don't miss it at all. Waiting for you there. Discord will be still the same server we will use tomorrow for all communications. Recordings of all talks which we have today here will be available soon on our YouTube channel. I think we're done for today. Thanks again for being today with us. Have a good evening. See you tomorrow. Java is still on. Bye.